Now coming to amines, the next compounds of nitrogen. Now let me tell you, amines, they are the derivatives of ammonia. Alright, they are regarded as the derivatives of ammonia, amines. And amines occur in the nature, widely we get it in the nature, amines. They constitute a major class of the organic compounds, we can say that, which is we are getting in the nature in the form of proteins, in the form of vitamins, in the form of alkaloids, in the form of hormones. We are getting, that is, the amines is being found, the nitrogen derivatives, we can say that, it's being found. So it is nothing but a derivative of ammonia. As I said you, amines, we are getting it, we are preparing from ammonia. Fine. Now amines, if you see the classification, it is being classified into primary amines, secondary amines, tertiary amines, and quaternary ammonium salts, so to say. On the basis of the, what you can say, the group attached to, that is, amines, we have got aliphatic amines and we have also got aromatic amines, we can say that. Now coming to one by one, that is, first is your, that is your primary amines, we can say that, that is 1 degree amine, we can say, that is primary amine, so to say, 1 degree amine. So the general formula is RNH2. The general formula is RNH2, that is a primary amine. For example, we can have CH3NH2, methylamine or methanamine, we can say that. CH3NH2, we can say the IUPAC name is methanamine. Remember it, that is the general IUPAC name of amines are alkanamine, we can say that. Alkanamine, general IUPAC name. Alright, or the common name is alkyl amine, we can say that. Common name is, like here it is methylamine and the IUPAC name is methanamine. Similarly, if I have C2H5NH2, it will be ethanamine. If you have C3H7NH2, propanamine, we can say that. So hence the general name is alkanamine, we can say that. Clear? Fine. Now next is your secondary amines. Secondary amines. Secondary amines, that is 2 degree amine, we can say that. It is nothing but R2NH. Sorry. R2NH. So one hydrogen atom is replaced by another alkyl group. You can see RNH2, in place of one hydrogen I have taken one alkyl group, R2NH. We can say that. So it is known as, the name will be N-alkyl alkanamine. It is N-alkyl alkanamine, we can say. For example, if you are having CH3 whole twice NH, you can write the structure in this way also, CH3NH-CH3. So what is the name? It is N-methyl, you can see it here, N-methyl, any methyl you can take it, N-methyl, then methanamine, we can say N-methyl methanamine. Let me write it this one properly, methanamine, N-methyl methanamine, we can say that. Clear? This is your secondary amines, we can say. Now we can have also 3 degree amines, we can say 3 degree amines, we can have it. So 3 degree amine is what? R3N. R3N is your 3 degree amine. The general formula is R3N, like CH3N, CH3, and here CH3, because nitrogen can have 3 bonds, so 3 bonds is there. So what is the name? It is N, N dimethyl, 2 methyls, or this 2 methyl, or this 2, whatever you can say that, N dimethyl methanamine, we can say that, N dimethyl methanamine. Now in secondary amines and tertiary amines, we can also have mixed amines. Mixed means different alkyl groups, we can say that. Like I have gave the example of same alkyl group. Here also you can see the same alkyl group. Here you can have different alkyl groups. Like suppose you can have a C2H5, CH3, C3H7. So the one which is having the maximum number of carbon atom, that will form the primary chain. That will form your root word, and the other two will be your prefix. For example, CH3N, C2H5, and here it is C3H7. So these two are your prefix, and this is the root word having the maximum number of carbon atoms. So alphabetical order I will use to write the IUPAC name. So what is that? N-ethyl. It was N dimethyl, na? 2 methyl was there because same alkyl group. So it is N-ethyl, N-methyl, N-ethyl, N-methyl, propanamine. We can say that. propanamine. N-ethyl and methyl propanamine. Okay. So this is your mixed amine, we can say that. It is not a simple amine, it's a mixed amine because we have got different alkyl groups attached to it, so to say. Clear? Now, next is depending upon that is what you can say, another one, that is as you can see it here, that is nitrogen is, all the bonds of nitrogen is satisfied. So depending upon that is the salt, the halides which is attached to it, we are having different types of 4-degree amine, that is known as quaternary ammonium salt. It is said to be as quaternary ammonium salt or quaternary ammonium compound, so to say, we can have it, whose general formula is nothing but R4N plus X minus. Why is N plus? Because nitrogen already the 3 bonds is satisfied in case of 3-degree amines. So one lone pair of electron it gives to halogens. For example, we can have CH3 whole 4 N plus Cl minus. It is what? Tetramethyl ammonium chloride. Because the general what you can say, general formula I'm saying, the formula from where we got it is nothing but this one, NH4Cl, where 4 hydrogen is replaced by 4 CH3 group. So hence it is tetramethyl, and what is the basic structure? Ammonium chloride. So tetramethyl ammonium chloride. So this is your known as nothing but a salt, tetra alkyl ammonium compound salt, which is also called as quaternary ammonium compound or quaternary ammonium salt, we can say that, which comes under 4-degree amine, so to say. So we got it 1 degree, 2 degree, 3 degree and 4-degree amines, so to say. If you want to draw the structure of this, it will be R, N, R, here R and here X. Alright, there is, we can say, plus and minus, we can say that. Clear? We can have the structure in this particular manner, we can have it, or you can put it outside also, R, N, R, R4, no, sorry, R4. So one more we can have it, so hence this here and X minus, yeah, now it is correct. R4 and plus X minus, we can say that. Clear? Now, next is depending upon the alkyl or the aryl group, we can have, that is aliphatic amines, and we can have aromatic amines. Till now, I was talking to you all about the aliphatic amines, till now, whatever, because I have put alkyl group only. Now, if I put the aryl group, that is your benzene ring, if I put it, then what I get the structure is, you can see it here, NH2. So it is known as aniline. Aniline, we can say that, or 1-degree amine or benzene amine, we can say that. Benzene amine, we can say, or we can say aniline, which is your 1-degree amine. Similarly, we can also have just like your primary secondary in case of aliphatic. In aromatic also we can have primary secondary. Alright, so here what you find, that is N, here H, and one more benzene ring. So it is diphenylamine, so to say. Let me draw this one properly. It is diphenylamine. 2 phenyl groups are there. Diphenylamine, it's a 2-degree amine, we can say that. Similarly, here another H, I can replace it by another aryl group, another benzene ring, we can say that. So it will be your triphenylamine, which will be coming under 3-degree amine, we can say that. This is 1 degree, this is 2 degree, and if this H is replaced by another aryl group or another benzene ring, it will be coming under 3-degree amine, so to say. Clear? So we can have it in this particular manner, the aryl amine. Similarly, we also got we are also having alkyl aryl amines. Alright, or we can also say aryl alkyl amines. Alright, aryl alkyl amines also we can say that. What do you mean by aryl alkyl amines means? Now see, this is your aryl group. Suppose we are having this alkyl group attached to it. So this is called as aryl alkyl, and this is your amines. So aryl alkyl amine, so to say. Now this name I said it is a diphenylamine. What is the name of this particular compound? It is phenylmethanamine. We can say that. Phenyl is a prefix. Methanamine, 1 carbon meth. Methanamine, phenylmethanamine. We can say that. Clear? Similarly, here also we can have what you can say another, that is H can be replaced. One H can be replaced by another group, which can be done. Alright, and we can have another, what you can say, aryl alkyl group can be put here. How? See here. See, CH2, and this is another benzene ring. So this is again your 2 degree aryl alkyl amine, so to say. It is 2 degree aryl alkyl amine, so to say. In this way, we can have 3 degree also. This H can also be replaced by CH2, another benzene ring, we can say that. Clear? So in this way, we can have alkyl amines, that's aliphatic amines, we can have aromatic amines. Got it? The previous one, I've rubbed it already. That is aryl amines. We can also have aryl alkyl amines in this way. Alright, the naming you understood. Basically, you have to remember the name, that is your nothing but your aniline, that is N-phenyl methyl amines, we can say that. And the primary, secondary, tertiary, all these amines, you have to remember the name, we can say that. Now coming to the structure of amines, if you see the structure of amines, then here amines shows sp3 hybridization. Here amines, it shows sp3 hybridization. How it is? See here. So the nitrogen is a central atom here, which contains a lone pair of electrons, and this is your R, and this is H, and this is your another H, we can say that. Let me write it in this way, it is good now. So this is your tetrahedral structure, where that is a nitrogen atom. It occupies the central positions, we can say that the nitrogen atom occupies the central positions, and one hybrid orbital, you can say that, contains a lone pair of electrons present in it, whereas the remaining 3 contains 1 electron each. Remaining 3 contains 1 electron each, and in this way we get it. So we can have primary amines. In this way, this hydrogen you replaced by another alkyl group, so it will be your secondary amines, and this hydrogen if you replace another alkyl group, this will be a tertiary amines. Alright, so here the nitrogen atom, already I said you, is in the state of sp3 hybridized state. sp3 hybridized state, the nitrogen atom is in the state of. Alright, sp3 hybridization, fine. But one thing you have to remember it. Due to lone pair bond pair repulsion, the bond angle in 1 degree and 2 degree amines decreases from 109 degree 28 minutes. Now this is your 1 degree amines. Alright, and this will be your, you can take this H or this H, anything you can take it. So in this way, this will be your nothing but your secondary amines, so to say. We can say this is your secondary amines. Clear? Now this will be of course far apart from one another, this two alkyl group, because they are going to repel one another. Due to repulsion, it will be far apart. That already I have studied in class 11 in VSAPR theory. They will arrange itself in such a manner. So coming to the bond angle, what I was saying, that here the bond angle is, if it is sp3 hybridized tetrahedral, so bond angle is 109 degree 28 minutes, so 109.5 degree. The bond angle decreases from 109.5 degree to 107 degree, almost, we can say that, 107 degree. However, in 3 degree amines, due to steric hindrance or steric repulsion, the bond angle increases. Got it? It is 108 degree. Because here all the 3, in case of tertiary amines, here you can see all the 3. So they suffer steric hindrance or steric repulsion. Because all 3 are alkyl groups. When they come closer to each other, they will suffer steric hindrance or steric repulsion. So here the bond angle slightly increases. Slightly increases means, generally what I said, from 1 degree to 2 degree, the bond angle decreases from 109.5 to 107 degree.